Day 153, Magnetic Fields. Today's purpose. Magnetic field lines show the direction that a magnet pushes or pulls on things. I will draw the shape of the magnetic field lines. I will learn why some materials are magnetic and others are not. Relevance. Just as gravity works at a distance, so do magnets. This lab shows how the forces of magnets vary in space. The magnets are used for a bunch of technologies on a daily basis. Examples include cell phones, motors, hard disk drives, and fridge magnets. Success. I will draw diagrams of magnetic fields. The equipment. Magnetic filings tray. What this is, it's a 2 layers of plastic with about an inch worth of baby oil on the inside. It completely fills it up, and it's about an inch thick. And in this baby oil, we also have some iron dust, iron filings that can float around and sink to the bottom. And we're also going to use 3 bar magnets with this and some white paper. Part 1. Place a bar magnet on a plain sheet of white paper. Hold the filing tray upside down for a moment to mix up the filings, and then place it on the paper. The filings will line up with the magnetic field of the bar magnet. If clear patterns do not appear, try flipping the tray over. If that doesn't work, ask the teacher to recharge the magnets. Which of the drawings best shows the way the filings line up? Okay, so each one of these, the gray rectangle represents the filing tray. Then we have the little magnet in the middle. And the powder on the inside, the iron filings, should kind of line up to make one of these patterns. And I don't have a filing tray available to me right now as I make this video, so I'll just tell you that the answer is letter C. All the dust particles line up sort of like this. Okay, now look at the drawing that you circled. It is not a complete diagram of the magnetic field. A complete drawing should include arrowheads on each line. These arrows indicate the direction that a tiny north pole would move if it were placed on the line. Think about how magnets work and draw the arrowheads on the drawing that you circled. So if I think about a little tiny north pole right here, it's going to get repelled by that north pole, so it's going to go this way. So I'm going to draw the arrowhead going in that direction. If I had a little tiny north pole right here on that line right there, it's going to get repelled, pushed away by this north pole, but at the same time it's going to get attracted to this south pole. So it's going to move in this direction. I'll put the arrowhead there. So I'm going to put all the arrowheads pointing towards the south pole. That's the way it works with all magnetic field lines. The arrowheads always go towards the south pole. Another way of saying this is that the line's arrows represent the net force on a tiny north pole. Since there's only one net force at any particular point, there can only be one line at any point. Therefore, magnetic field lines cannot cross. Part 2. Place 2 bar magnets on a plain sheet of white paper. Lay the magnets in the orientation shown below and sketch the lines of the magnetic field. Between each trial, hold the filing tray upside down for a moment to mix up the filings. Be sure to draw arrowheads on your drawings. Okay, so it should have little dots line up sort of like this, the little iron filings. So, what does that mean for making our arrows? A little tiny north pole, if it was placed right here, would be pushed away to the left from this north pole and be pulled, attracted towards this south pole, again in the same direction. So I'm going to draw my arrow going in that direction like that. If I had a little north pole right there, it'd get repelled by this north pole, be pushed up, but again pulled down by this south pole, so it's going to get traveling in this kind of a direction. So all of these lines are going to be arrows pointing towards the south pole. Over here, it goes away from the north and towards this south, so the arrowhead is pointing to the right in this case, but it's still pointing towards the closest south pole. In the next one, your filings should line up in this kind of a pattern. That's what you'd see when you looked at the tray. So when we draw our magnetic field lines, it's going to be from the north to the south along these patterns of dots. Next page. Okay, different orientation, and we're going to be drawing from the north to the south, and the dots would kind of go around like this if we did this in real life. So draw the field lines from the north to the south, arrows going from the north to the south. Something along that lines like that. Number 4. This is how the filings, the iron filings, would appear if you did it in real life. So to draw the magnetic field lines, we trace over these, and the arrows go away from the north towards the south. Notice that lines cannot cross, and they always go away from the north. They diverge here if they can't find a south nearby. Okay, here we go. What's this next one? The filings would line up like this. And so the pattern, if we draw lines, would be from the north to the south. Towards the south. Ideas to know. Step number 1. When drawing field lines around a single magnet, draw arcs going from the North Pole to the South Pole. These are always existing around every magnet. Step 2. When drawing field lines between different magnets, first draw a straight line from the North Pole to the South Pole on the separate magnets. Then draw arching lines on either side. The lines cannot cross. So I did that up here. I drew a straight line from north to south and then arcing ones on both sides. Up here, directly from the north to the south and then arcing lines on either side. Step 3. When drawing field lines around different magnets, the magnetic fields of the poles repel each other. This is shown by drawing lines diverging from each other. Okay, so try to do that with these two orientations here. Pause the video while you try it, and then I will show it. Okay, first step. Around a single magnet, we're going to go from north to south. Around each individual magnet, north to south. And then we're going to draw a straight line from the north to the south. Straight line. And then arcs on both sides. Here we have a south and a south kind of close together. We're going to draw diverging lines there. They do not go one together. They are spreading apart. And then I can add some more in the same general pattern. Oops, I drew my arrowheads in the wrong direction. Drat. Going in this towards the south. Always towards the south. Okay, next one. Around each individual magnet from north to south. And then here we have two south poles close together, so they're going to have diverging. I did it again. It has to go towards the south. There we go. North pole, north pole. Here they're going to be going away from each other. And then I can fill in some extras just to make it more complete. So, at this time, you can do homework 153, and that will be on Schoology.